welcome at the first edition of ScalaSphere, the ScalaSphere event, which is, I think, pretty unique. It's focusing more on the something that you use on a daily basis in your job or hobby project. That is DevTools, development tools. So you will see the examples of how to use them in different types of projects today. You will see also how they are made to some extent, and so you will get to know how a little bit more details. And you will also get the opportunity to actually give feedback to the authors of those tools usually, because most of them are here, and most of them will have talks today or tomorrow. So I think it will be pretty interesting. I hope it will be pretty interesting. Feel free to grab anyone from the team if you need any help or if you would like to give any feedback. So that's basically it. So we can start. Thank you. And let me introduce the first speaker. That will be Iulian Dragos. Iulian Dragos has been in the Scala ecosystem since the beginning, still in the Martin Soderski group on EPFL. Then he joined from the day one to TypeSafe, and he led the Scala Ide team. And right now he's leading Spark team within TypeSafe. So welcome, Iulian, and
thank you very much. Can you guys hear me? Better use the microphone. Hello. Okay. Thank you, Rafal, for the introduction. The idea of this talk came last fall, I think, when I was invited to speak at Scala World, and I realized that a crushing majority of talks in any Scala conference were about libraries, and very, very few talks were about Scala tools. So you would think that Scala tooling is a solved problem, right? Nobody cares to talk about that anymore, but the reality of it is it's far from that, unfortunately. Of course, we're much better than 4 years ago, let's say, but there's still a lot of work to be done. So basically at that conference, I wanted to raise this issue and tilt the balance slightly towards tools. And today, matters look brighter because we have a conference only about that. So Rafal wanted to prove me wrong. Next year, I cannot use this line anymore. Probably there are more Scala tools talks now at this conference than any other than about libraries. I hope so. So I'm a tooling person myself. As Rafal mentioned, I worked for 4 years, maybe even a bit more, on the Scala IDE for Eclipse. And before that, I worked on the Scala compiler during my PhD at EPFL. So today I'm going to talk a bit about the lessons I learned during these years. The title is very general, so it allows me to talk about anything, right? So I hope that some of those lessons will be interesting. Some of them are quite general. You'll probably recognize them from other projects. Some are very specific. And in the second part of the talk, I'll look a bit more at the larger context or larger landscape of Scala tools, not just IDEs, which is, let's say, where I come from, and maybe suggest a few directions where I think we should put more effort or where we should head. Okay. So whenever we talk about Scala, it's almost impossible to escape the comparison with Java. We run on the JVM. Scala is a JVM class-based object-oriented language, and so on. So if you look at the tooling space, Java did really spoiled us. 10 years after Java was launched, there were a bunch of IDEs, code coverage tools, profilers, you name it. For Scala, unfortunately, it's not really the same. We have decent IDE support. I think both Eclipse and IntelliJ are doing very good. I think Enzyme is actually a very good IDE as well. So I think on that front, we're decent. Still work to do, but decent. But the same cannot be said about the other tools. So let's first define what I mean by a tool. And I think Rafal already defined it, but I'll just repeat it. It's a program that is primarily designed for the use or benefit of developers. I would not include a testing library or a mocking library as a tool. I mean compilers, profilers, code coverage tools, bug finders, static analyzers, build tools, and so on. And the Scala ecosystem definitely sees a lot of innovation in libraries because Scala is practically designed for library authors. It's a scalable language that lets you grow the language through libraries. So it lets you write libraries that sort of embed naturally in the language. So, and that has been taken advantage of by many people, and I think that's awesome. It shows that it works. But much less in tools, and I think it's exactly for the same reason. Scala is a very flexible language that is hard to properly treat in a tool. There are a ton of feature interactions. You may not think about it. So now let's see how all this sort of played out in developing the Eclipse Ide for Scala. So we have to go roughly 4 years, go back in time, 4 years. It's 2010, maybe beginning of 2011, so okay, maybe a bit more than 4 years. Everybody loved us. Twitter loved us, LinkedIn loved Scala. Scala was touted as the apparent heir to the Java throne, right? We just had one more little thing to do, fix this IDE problem. I mean, there was already an Eclipse plugin. How hard would it be to fix it, to really work? So the first question wasn't really actually asked when we took over, or let's say joined as a software engineering team inside TypeSafe. So TypeSafe provided the money, hired the people, and said we're going to work as an open source contributor to the Eclipse plugin for Scala. So the first question wasn't really asked at all. But I think going back, we probably just put it aside. Should we rewrite it, or should start from scratch, or just fix it? And I don't want to. I want to be frank here, even though this is maybe not extremely nice to say, but it was a very buggy code base. It didn't really work. So we decided to fix it because we thought it's such a huge effort to start from scratch, and this is just a couple of months from our first release, and then we can just iterate. So an example, what do I mean? One of these shortcuts that we wanted to fix. How many of you have used Aspect J in your life? Okay, quite a lot of people. Okay, so the idea, which I think was very bright, was let's use Aspect J to weave into the Java tooling, the Java plugin on Eclipse. And you know, if we could only make Scala source code look like Java, everything would come for free. All the features in the Java plugin for Eclipse would just work for us, right? Very clever idea. It's quick to do. All features, you don't have to program anything anymore. You just have to reliably shoehorn Scala ASTs into Java trees. So we said, let's do that. I mean, it was already in there. It just didn't work very well. Now, the first problem, we saw it very quickly, was version fragility. This was not API. Eclipse would change internals of the JDT in minor releases. So we very soon had to actually fork the code base to support. I think back then it was Eclipse, what was it? Before Helios, I forgot, whatever. And then Juno came along, which was a complete mess because it changed so many things internally. We had a few months to catch up, so we had forked the code base already just for Eclipse compatibility. The JDT internals are really hairy. So if anyone tells you the Scala compiler internals are bad, tell them to go look at the Java Eclipse compiler and then come back. And I think maybe the most fundamental problem was that Scala is not Java. It's simply impossible to translate to Java some Scala constructs. And the worst part is that those are fairly common Scala constructs. Those are not super involved things. For example, just top-level objects are already a pain to translate to Java. So, of course, it would never work properly. So yeah, this was a can of worms that, you know, we just dug our grave deeper and deeper. So it was eternally unreliable. These are a few of the features we got for free and that didn't really work. So the JUnit test runner, it took years to get to work reliably, and actually we just rewrote the discovery mechanism. The debugger, same thing. Run a Scala, this is my favorite. You would right-click on a source file in your editor and choose Run as Scala. Except that for Eclipse to know if there's a main method in there, it took 15 or 20 seconds just because. This was all inside the Java development tools code that has a ton of caching, but we didn't know exactly how to take advantage of that caching because JDT internals were horrible, and we didn't really figure out. So finally, we had to rewrite that part from scratch as well. Also with more weaving, obviously. The outline view, it showed a lot of internal mangled names because we had to expose them to the Java tools, just that Java code can call those names. Type hierarchy, and so on. The list goes on. This is not even a full list. Another example, the Scala debugger. We did exactly the same overestimation of the effort. It wasn't really that hard. So a guy called Luc Bourlier, okay, he worked on Eclipse Java tooling before, so he had experience. I give you that. It took him about 3 months to write a fully featured, or a full, let's say a full Scala debugger for Eclipse using the clean APIs without using AspectJ or anything. And we got 90% of Java functionality. What we were missing was maybe exception breakpoints. Fine, not a big deal. Maybe run to line wasn't working in the first release. Not too bad. But this was on a clean code base. So here, again, maybe it was our inexperience or just our fear of starting from scratch. But here, this really worked well. And my favorite, this was just a few months ago. I don't think Andrei is here, but a completely new contributor. This was his first contribution. Rewrote the outline view from scratch. It took him probably about 2 weeks, I think, with a pull request review. And it's in, and it's working fairly well, I would say. So if I were to draw a lesson, I think it's, well, a start, to have a clean start and rewrite something, it's not such a scary thing, especially if this is a project that's going to go for 4 years. And it was clear from the beginning we would maintain the Eclipse plugin for years. It wasn't, let's say, a few months project and then move on to something else. And if you're now thinking about Dotty, I think it's a good thing. It's probably the same reasoning there as well. Now another early mistake was having releases when the thing is done. So the first release was 2.0. The reason why we chose to name it 2.0 is because there were a number of milestones for 1.0, and we wanted to clearly state this is a plugin that works and has 3 features that work reliably. Report errors as you type, so without spurious errors, hyperlinking, and completion. I think these were the features we wanted, so it was a feature-driven release. It took us 1 year, just fixing and finding new bugs and fixing more. The second one, so 3.0, took us 1 year and 3 months. And the 4.0 one took us 1 year and 6 months. So obviously, in between these things, there were some maybe milestones and some nightly builds and so on, but no, let's say, stable release, or at least no major one. So you're maybe asking why. Because we were saying many times, let's just fix this one more thing and then release. And then we were on moving sands. We had the Eclipse internals moving around. We had the Scala compiler moving around. And we were basically fighting all of these things. And some new regressions came along. And then dogfooding. Everyone on the team was working on nightlies. So that's a good thing, because you just fix things when they annoy you. But you also don't feel the pain of a regular developer. We didn't care there was no release, because we had all the new features and all the bug fixes in our daily development environment. But the whole world was waiting and didn't have access. We didn't realize, but nobody's using milestones and nightlies. Don't kid yourself. Less than 1% of our downloads came from milestones. Maybe, yeah, a successful milestone had 1,000 downloads, but we had 100,000 downloads for a full release. So feature-driven releases were a mistake. And release often, you hear it so often that it sort of just goes past you, or it went past me. It's really underrated. And I think dogfooding has one downside, and that is that you don't feel the pain of your users. So time-based releases are definitely superior, and I think one of the arguments is that it keeps your users engaged and the project is alive. I mean, in the 1 year and 6 months between 3 and 4.0, I think most people just moved to IntelliJ because they thought Eclipse is dead. It was probably more active than ever, but we just didn't release. And I don't blame them. And I think that just releasing a lemon, a really crappy release that is followed by a bug fix a week later, is way better than not releasing anything. So just show that you're active. So the next 3 releases, 4.1, 4.2, and 4.3, are roughly 3 months apart. And I think this is mostly due to the help we get from VirtusLab, who took over the release process and decided together that time-based releases, whatever we have, we just release it. And I would say the project is always in a good shape to be released. We have very few regressions. I think we have a fairly extensive test suite now. And we're fairly confident we can release at any time. So we try to shy away from saying we need this feature in, although we still have this from time to time. OK. So now let's talk about the Scala presentation compiler. So this is, let's say, the component that gives all the smartness in the IDE, and I think every IDE has one, right? So obviously, the Scala presentation compiler is just the Scala type checker, what you have in Scala C. Since it's the same type checker, the big advantage is that you have a very precise type checker there, so all the errors are real errors. At least that's what we thought. And it's already done, we have the type checker. Why should we write anything new if we could only make it asynchronous? I mean, there's just one more small thing we had to do. A batch compiler is fine. It can be slow, but you just wait. When you're typing, you can't. It has to be done in the background. It has to be responsive, and so on. Now, the compiler, unfortunately, it's really profoundly single-threaded. So we had a ton of these spurious errors that we thought are by design, they cannot happen. We had even more than others. And the problem was precisely this multi-threaded nature of Eclipse and the fact that the compiler really expected to be single-threaded. And on top of that, new features were being developed in Scala C. I don't know, this was maybe 2.8, 2.9. Named arguments, they were new. That was probably the feature I hated the most during those years. I couldn't even use them myself, even though they were very useful. But there were so many errors related to them. Finally, we fixed them all. But reflection and macros. 2.10, I think, introduced reflection. That was actually just taking a big chunk of the compiler, refactoring, and putting it into the standard library. This slowed us down by months. The only way we could guard ourselves against regressions was to build the IDE on Scala snapshot builds, nightlies. So they would break us almost every other night, or every other day in the morning. Well, it doesn't build anymore. Let's see what happened. Or even worse, it would build, but a bunch of tests would fail. So reflection was probably the single most time-consuming event in the history of the IDE. I cannot complain enough about it. So this was a time sink. That 1 year and 3 months for the secondary 3.0, probably maybe almost half of it was just keeping up with the 2.10 release. And nobody was using 2.10 at that time. You realize 2.9 was the main. Everybody was using 2.9. 2.10 was months ahead. Now, my favorite is binary incompatibility. There's no real API on top of the Scala compiler yet, and neither binary compatibility. So that means any dependency that we had also had to be rebuilt for the Scala nightly, and that may fail. So now maybe you heard about the community build. So the Scala team has a bunch of projects that they build every night on every pull request, and then they see if anything is regressing, and they can take action. Now, we were the community build back then. So the IDE team would document these regressions. Sometimes it's just a type inference bug. Your project doesn't compile anymore because the type is inferred differently. Now, spend some time to see if you can minimize. Spend some time to see if it's a real bug, a real regression, or it's actually a correct, maybe a type error that had to be in place from the beginning, so you have to modify your source code, which is not your source code because it could be from Scala Reform or from SBT or God knows where. So we were the community build for a while. We had to rebuild everything from scratch, so we decided to use zero Scala dependencies. We were lying a bit. We had the Scala Reform, but that was such a stable code base, we didn't really feel any pain in rebuilding it. But we didn't use, for example, Scala test. We used JUnit because we didn't want the pain of building Scala test and using it for our tests. It also means the whole world around us is using Scala test, but we don't. So we don't care about Scala test integration either, right? We had to, fix other things. Right now we have a much better solution. So the Scala, there's a pull request validator that runs the IDE test suite. So sometimes if you ever contribute to the Scala compiler, you will see that the IDE tests are breaking, and you're probably very annoyed by that and say, why the hell do we have to run this guy's test suite? Maybe I sort of explain a little bit why and why this is such an important thing for the IDE work. Now SBT, this is the second beast. I should put a bigger picture there, but so we need to build inside an IDE. So what is most logical thing to do is, well, to use a build tool to do that. So SBT had many things going for it. Actually, back then, I think everybody loved it. I think that changed after 0.10, but back then it was really the beginning. We didn't know what was coming. So we said, yeah, we're going to use SBT. It handles multi-project builds. It has an incremental compiler. It's an easy decision. Actually, we had a builder, built sort of from scratch, a simple one, but it worked really well. But so let's just standardize. It's important to reuse code. Don't rewrite it. Now, the problem is that SBT is a very strange beast indeed. It can build any Scala version, but itself is built with one Scala version. Let's say back then 2.8. Now it's 2.10, and probably it won't change even when 2.12 is out. So we needed to rebuild being a Scala dependency with a Scala snapshot build, 2.11 snapshot. Now the other thing is SBT has a code base that is probably clean, but it's extremely hard to understand for somebody outside. And I didn't care on contributing to SBT. I just wanted to have it running in my nightly builds. So we had probably more regressions in building SBT than any other part of the code. Because the Scala compiler was moving, and maybe the type inferencer worked differently, and one of these extremely complicated types inside of SBT failed to compile. So this really broke the build many times. At some point, we even had our own fork, but then we managed to merge back. The other con was that it's actually slower than we had before. I think this is just because of the way, well, it's also more safe, let's say. So we had something that was a little bit too optimistic, but very fast. So maybe this is not too bad. So if you have to build something, you have to be careful when choosing the building blocks. So we could fork SBT and compiler. I mean, if we forked the Scala compiler, we could have just stripped everything away except the type checker. That's all we needed, and maybe merge patches as they came in. The type checker is maybe relatively stable. There are some bugs, but I think a lot of the work these days is concentrated in the backend. So that would have been a viable option back then. Or you can start from scratch, and even if this sounds crazy, I think it's not a bad idea. And JetBrains did just that. JetBrains wrote a Scala type checker. Are they behind us now? I don't think so. So we compromised. We managed to converge on one Scala version and still support projects with different Scala versions inside Eclipse. I don't know if you remember this very annoying limitation for a while. If you were using Scala 2.10, you needed a 2.10 build of your Eclipse plugin. So if you wanted a 2.10 and 2.11 project, you had to have 2 workspaces and 2 Eclipse installations. Very, very annoying. So we managed to do that, and here the Scala team really helped us. We worked with them to add a compatibility mode to the Scala type checker. So you basically have a source flag. You say, I want to work in 2.10 mode. That means your project can have 2.10 dependencies, and everything is in there, and it will type check as if it was on 2.11. That means a lot of knobs or if branches in the Scala type checker between 2.10 and 2.11. For SBT, we just decided to live with the pain. OK, so now we had all this fun. We said, let's let others join the fun. So let's have plugins for the Scala plugin. And this was really because we didn't want to add Scala test integration, because we weren't using it. So we said, what if others want to complement the functionality of the Scala IDE by writing their own plugins? So we have 4 or 5, maybe now. These are some examples. And this was fine. Others can maintain the tooling set. And for Scala test, it worked really well. Bill Vanners and Chi Sang, they really do a good job. They do maintain the Scala test plugin for Eclipse. The release cycle can be faster because we started to realize it's a bit ridiculous to wait a year between releases. And these tools can release faster because they're independent. Now, one of the issues was now we had a release train. We had to coordinate because we put out a release candidate. And the first bug comes an hour later saying, I cannot find Scala test. I said, well, this is the core plugin. Scala test is a separate plugin that you have to talk to the people who maintain it if it's not available. Obviously, that didn't work. So we started talking to all plugin writers, just please be aware, tomorrow we're going to release, can you also release? Or just build them ourselves. The second one was we had cross-project changes between core and one of these plugins. They couldn't now be done in an atomic way because they were separate repositories. And this was very hard because we decided to have a stable API with semantic versioning so people know predictably when binary compatibility is broken. And we had a lot of cross-cutting changes. We maintained some of those plugins ourselves. So this was pain because you had to merge pull requests in a certain order so all the pull request validators pass and so on. Not hard, but just busy work. Now the problem is that these plugins didn't really take off. We had a couple, but not that many. The build process became more complex. The release process became more complex. And the API was maybe this is controversial, maybe Simon would contradict me, but the API was an effort without a clear win. I think the win was that we actually went through the whole source code and tried to clean it up, and that was good. But ultimately, the API users we're still waiting for them to come. So I would say if I were to do these things again, I think a single repo, at least for the things we maintain, is probably better. So you can be modular with one repository. And you can release from the same repository at different pace from different projects. And since now I'm working now as an open source contributor to Spark, a very successful, very scaled or very large Scala project, they do have a few libraries and the core in the same repo, and it seems to work fairly well. And I think the advantage is precisely cross-cutting changes and simplicity. It's just in one place. A few words about the open source software dynamics. I don't want to talk too much about it, but this was news to me when I started. So people complain no matter what. You can, work the whole night, and in the morning people will rant, and they don't know that, so that's okay. But it's also hard to get bug reports. People can just say nothing works on Twitter, and that's it. And you would really like to fix it, but there's no bug report. And contributions are very hard to get as well. But even bug reports would be good. So one thing I learned is that if instead of getting upset and depressed and saying that this world, I'm disappointed in the world, or I lost hope in the world, actually people respond to polite and constructive discourse. If somebody tweets on Twitter that the Scala ID is really crappy, and I say, can you please explain what didn't work, and we can help you, or come to the mailing list, most of them actually do. And most of them change to be maybe not contributors, but they do file bug reports. Not all, but that's actually rare. For contributors, I think timely pull request reviews is really important. I think you have to guide in the beginning people to show them what they did wrong, what they could do, and what they could work on. Easy stuff to start with. It's very daunting when you go to a project with 1,000 tickets and choose something to, maybe you have something that really bothers you, so then it's easy, but sometimes you just don't know where to start. And I think it's important to merge PRs, to encourage people. Sometimes they're not the way you would write them. Maybe not at your standard, or you just know a better way. Sometimes it's not your highest priority. Maybe they want to work on something you don't care about. In both cases, I think you should merge it and iterate. Maybe you fix it, you bring it to your standard later, and ask that person to review your code. And this is controversial. I know projects that have a very high standard and they will not lower it. I think this is a much better way to gain help. And then those people will stay with you. Okay, so to close, I have a couple of ideas about the no IDE movements. I'm personally not using only Eclipse as an IDE. I'm using Sublime Text. I'm using I tried Atom. I'm not a big fan of it, but I'm trying to see what's happening in these days. And I was using Emacs for a long time, and I'm still using it as well. So there's maybe a Cambrian explosion of a new breed of editors. So Visual Studio Code is actually the one I'm now into the most. I like it a lot. Light Table was maybe the first to sort of make a splash. There's Eclipse Ide, if you heard, the web-based IDE. All of them, I think, have in common a very smooth and no-clutter interface, and maybe not a complete environment, but a very smooth and quick favor quick editing. But I still think their goal, or in the end, they will end up being intelligent. They already have Git integration, they have lint, they have completion, and so on. Maybe they don't have a builder, but they do have, even Sublime has a builder interface to run your build behind the scenes. So I think it's not a movement against the idea of a development environment. It's a movement against the idea of cluttered, heavyweight interfaces. And I think that's great. Web-based IDEs, on the other hand, I still cannot get the hang of them. I don't see exactly where is the sweet spot except training. It's a very easy way to get started, zero setup, things are working for small projects. I don't see yet how this will evolve into something that you'd use in your daily life. And collaboration, which is sort of the main idea when you think about web-based anything, I think GitHub may have killed that, because GitHub works really well for collaboration in a team. So one way maybe is to have an IDE that just integrates with the pull request process, and it gives you intelligence when you review code. You can hover to see the Scala doc of a method, you can hyperlink, and you can basically not edit, but just have all the other information you'd have in the IDE. Okay, so I have about 10 more minutes, so let's talk a bit about some other popular Scala tools for the closing time. So obviously, when we look at build tools, there's a clear winner, SPT. I think the absolute numbers don't matter that much, but what I found interesting was that Gradle and Maven are pretty much head-to-head. Of course, this is all data from GitHub, obviously not scientific. We have no idea what's happening in the enterprise. For code coverage, S coverage is the clear winner, but if you look at the numbers, it's way below SPT, so it's not a standard. I don't think everyone would use code coverage, but I think more people would if this really worked. And I have to say, I tried it a few times. It didn't work very well. So I think S coverage is a great tool that needs more love. Code analysis. And here we have 4 contenders. Also a clear winner, Scala style. Word remover and scapegoat are a bit more advanced, because what they're trying to do is look at your types and provide much stricter guidelines, while Scala style is really about how you format your code, if you have line length above something, and so on. And the last one is Abide, which I put there just for fun because I had some history. It wasn't even released, but I think it's the best at some point. So now the interesting fact is the #1 complaint about Scala, the language, not the compiler, is complexity. But very few projects actually use the code checker or a code checker, and I think that's because they're not capable enough yet. So why don't people help with these tools? Why don't they work and bring them forward, push them forward? And I had a bunch of things here that I wrote more like a tongue-in-cheek at my Scala World presentation. They don't get you a conference keynote slot. It's not a very glamorous field to be in, to be honest. It won't increase your, if you're a consultant, your hourly rate, and you won't get many thanks, but plenty of bug reports. And I think I was wrong with almost all of them. I was corrected quickly by somebody who will speak later or tomorrow. For him, it worked. So, maybe that's good news. Now, why should you work on tools? And I think, for me, this is just because it's hard. I think most of you here are actually challenged by hard problems. And there's more problems to be solved in the tooling space for Scala than in a web framework, let's say, or in a concurrency framework. Even though concurrency is hard, every paper starts like that. And it's really rewarding. I mean, you're dealing with infinity every day, right? You have a grammar that can generate an infinite number of programs that are, respect that grammar. So you have to deal with that. And you have to basically prove yourself that you're handling all the cases. And of course, there's impact. And I think, again, another remark that was more of a Scala World remark. I think there's enough Monad tutorials out there. If you blog, find some other subject. So the problem with tools is that it's hard and thankless, but it's fun and impactful. So I think it's a balance here. You should do that. Now, why is it hard? I think one is time. You really need grit. When you start on such a project, it's not going to be 3 months. It's going to be a long time. There are no reusable components, and there's Scala binary compatibility on top of that. So it's hard to actually use if you're working on the compiler, of course. So the compiler API isn't there yet. Reflection isn't anything but experimental. And Scala Meta, I think Eugene will talk a couple of hours later about it, may give us this API layer. Everybody's very excited about Scala Meta, and I'm also very excited to hear what's happening these days. But my conservative approximation is 1-2 years in front of us, and I would really like to be proven wrong. Now, the bad news is that long times and focused effort means money, because nobody works for free, right? And Scala doesn't have Sun or IBM or Apple to build the tools for us. So you can guess what languages are each one about. But so what I think we should work on, and I'm going to try to be a little bit faster so I don't cut into the next talk, is a solid bug checker for Scala, solid code coverage. For me, these are a tie, A and B or B and A, whichever you like most, I think is the most important one. And the second Scala compiler implementation. I really want to see a second Scala compiler implementation. And the reason, it may sound crazy, and don't think Dotty again. Dotty is not a second Scala compiler implementation. It will replace Scala C, whatever they tell you now. It's not meant to be a second implementation that you can choose from. And this would force us a better specification. The Scala specification is extremely readable, and it's great for a programmer. I don't think it's enough to actually implement another compiler. And the JetBrains people can tell you more about it. So I think it should have a different focus than Scala C. It should be more about parallel compilation, a smaller footprint, and better Java interoperability. I think all of these things can be done if you think hard about them. So faster. That is the biggest complaint against the Scala compiler, not the language. And I think a healthy ecosystem has redundancy. I think we have to try different designs. Like in the world, you see different body plans or phyla, I think, the plural. Different body plans that compete with each other, and then one wins eventually. We don't have that in Scala, or very few tools have that. So pick one and work on that, and I'm sure you will, because that's why you are here. And there are tons of brilliant minds in the Scala world, and it's up to us to close the tooling gap. We cannot wait for IBM to do that for us, or for Apple. So there's a hackathon. Go to the hackathon, code, and tweet about it, and that's all I have. Thank you.
Maybe you have some questions. Are there any questions for Iulian?
How big is your team? How many people work on those Eclipse plugins?
Back when we started, we were 3. Then we grew to 4 people, and I think now how many are we now?
3, 4.
Again, back to 3 to 4. It changes because we have part-time work as well.
And how many contributors in the community, like outside your team?
That's a very good question. I think for a long time there was only one, Simon, here. I think in the past few months we have Matthias, who will talk just after me. I think that's a fantastic addition to the team. And Andrei, who I don't think he may. So let's say 3 people, let's say relatively constant producing things, yeah. I think it's very little for a project of this size, to be honest. Okay.
Can you go back a few slides?
Yeah.
I'm not sure I have a question, but I
do you know more or less on what part it was?
I think it was about the compiler.
Okay.
I'm not really sure I have a question, but
okay, let's go.
I forgot this. No, I right at the end of the second compiler implementation.
Okay, so that's really at the end, okay.
Right. So, all right. So the question was, what do you have in mind when you say better Java interop?
So there's a number of tickets about, for example, how do you call or how do you access a singleton object, a top-level Java Scala object from Java? I think this can be done. I think name mangling can be a bit more predictable. And I think some problems cannot be solved. For example, generic signatures, Scala to Java, they're not always translatable. That's clear, unfortunately. We know that. But I think, for example, let's see. There was a very recent bug report I looked at, and I think it had to do with either overloading overloading and var args. I think again, it's not that we don't know how to do it; it's never prioritized because there's other things to do. So I think we could probably, if somebody took 3 months to go through all of this, we could come up with a better solution. This is of course speculation. I didn't spend the 3 months yet.
All right, thanks.
Yeah. I think that's it.
Okay, if that's it, if there is no any more questions, so in 10 20